So we have Matthew McWirth and Emilio Orpeza today with us. Folks, take it away, please.
All right. Thank you, everybody, for coming to our talk. There's another AI talk happening in the amphitheater, but you guys are in the right location, so super excited. So today we're going to talk about agentic AI, but really through the lens of modernized identity and access management and security architecture controls that are really required today, especially when organizations are starting to integrate AI agents into their ecosystem. So we have a pretty, packed agenda here. So we're going to, talk about all of these things, but just a quick intro. So I'm Matthew McWirt.
Hello, my name is Emilio Orpeza.
And we work in Mandiant Consulting in our Security Transformation Services team. It's a fancy acronym or a fancy set of words. And what we do is we are on the front lines of helping clients reactively. When there's been an incident, we are the team that leads remediation. Then we also work with clients proactively to help them from cybersecurity transformation, deep diving into security architecture, cyber defense, and advisory. So what we are talking about is basically coming from the asks that we were getting from clients and what we've had to navigate clients through, especially in this age of agentic AI. So we're going to get started. But before we deep dive too much into the AI stuff, right? It's coming. But I want us to think about where we have come from and what is kind of the evolution that we're living through and we're experiencing over the past couple of years, right? When we think about the definition of an identity, what does that mean, right? We started off from the interactive side. So that's us as humans. And it kind of graduated to us as humans and then our devices, right? Our devices, what we are accessing data from is an extension of our identity. And I think in modern zero trust principles, the device and the human aspects go hand in hand, right? So that's kind of where we started with us as a human, and we include our devices, right? So that's from the interactive perspective. That's us hands on keyboard doing things. We also have programmatic identities. So these are service accounts, right? These are service principals in cloud. These are workloads. These are things that might not be interactive necessarily, but they're identities that are focused on doing a specific task or to execute a specific function, right? And now we've graduated over the past couple of years into AI, artificial intelligence, where you have the speed and scale and the breadth and depth of what AI encompasses. But AI, we have to think of agents as another yet extension of our modern day identities. Traditional IAM programs, right? They're in this box. They're the human, they're the interactive, they're the devices. They're the programmatic. Unfortunately, that box hasn't really extended at scale to include the AI. So that's what we are going to talk about today. We want to extend this box for everyone in the room. So after you leave, hopefully you kind of understand what that extension reflects and looks like. And very quickly, authentication has evolved over time, right? We started off with single factor authentication, simple username and password. It's where we all started at some points. We've now graduated up to MFA. So hopefully everyone in this room, in your organization, you went up that step. You're at the MFA level, hopefully. We also have our devices, right? Our devices, the identity, the human aspect, our MFA, and our device. That actually represents a very strong positive identity transaction, right? So now we couple that, and we've enhanced our ability to authenticate and our criteria. We can now look at attributes of that device or of ourself. We could look at where are we coming from? What do we want to access? What sort of additional challenge authentication is required? And we also take into consideration risk, right? It could be just based upon patterns or reflective of what we are trying to access and where we are trying to access it from and time-based duration of that session. But this is all required, right? Based upon, we used to be all on-prem, right? Now we are hybrid, right? So we're distributed identities, distributed workloads. We had to adopt this zero trust model. It's very important because what we're going to talk about for agentic AI, these same principles are still very relevant and important. It's just a different spin on it, a different way to do it. Very quickly, when we talk about visibility, right, we spend a lot of time focusing our identity and visibility detection programs just around the interactive side. So it's almost like the inverse of that slide 2 slides ago. We've done a fairly good job with the programmatic, maybe not so much as we've gone into cloud. Maybe we have some blind spots with workloads and other things. But where we've kind of fallen off the cliff, or where organizations will say that we don't have visibility, we're not confident in the audit capabilities or the traceability of our AI agents, is when we've kind of navigated here, right? So that's something else that we'll talk about. So let's talk about agentic AI. Just a quick primer, a quick background of what do we mean here, right? So an AI agent, right, you can hopefully read the definition there. Like some of the key traits that I equate to this is we have an agent that is autonomous, right? Means it can make real-time it can make real-time decisions based upon contextual information. It doesn't need a human to tell it exactly what to do based upon the factors that are in play, right? It's multi-threaded. It's going to be doing a lot of things simultaneously, interfacing with tools and APIs and other things. It doesn't have to follow a sequential pattern. It can be doing a lot at the exact same time. It's dynamic and adaptive based upon learned information and patterns, right? So if we think about an AI agent putting together what we know as a human, right, we can equate it to perception, right? That's the eyes and ears of the agent. There's going to be a trigger that's going to require that agent to do something. That trigger could be a prompt somebody inputs a request into. It could be an observation that the agent identifies based upon a pattern of data. It could be the way that the agent is integrated with an application. So that's the trigger. The perception is the trigger. The brain is the large language model, the LLM, right? So that a modern day AI agent is actually going to do something. It's going to execute an action, right? So it's going to break down what that trigger was into a series of steps and sequences that it can then go and execute. And that's the next stage. It's actually going to do something. It's going to take an action. This is all backed by memory, right? A modern day, agentic AI, memory is a huge aspect of this, right? Because it allows the agent to learn from previous experiences, maintain its current state, and adapt and enhance over time. So it doesn't have to start over. It doesn't have to start from ground zero every time, right? It's continually learning, continually enhancing. We think about the types of agents that exist. Now, these are like high-level summarizations for the purpose of this talk. But back in the day, it was like retrieval agents, very like narrow focus. They're kind of predicated on static models for the LLM and static data sets. Retrieval agents are going to find that information based upon whatever that perception was, whatever that trigger, and it's going to aggregate that information, provide it back to the requester. But then it's up to the requester to figure out, what do I want to do with this data? Do I want to extract it? Do I want to put it into a report? What exactly do I want to do? Task agents is where we've started to become more autonomous, right? So it's building off that retrieval agent. It could use the retrieval augmented generation, which we'll talk about here in a second, right? But it's actually going to take that prompt. It's going to take the data and it's going to do something with it. It's going to create an action. We have some examples of like what does this look like in the wild over on the right-hand side of the chart there. And where most organizations are going towards today are custom agents, right? So these are agents purpose-built for a specific set of actions and goals that are trained on internal type information and data. So the custom agent is kind of the hybrid of the two, but it's heavily customized, just as the name implies, based upon what the organization wants. So these are like purpose-built agents that organizations are deploying to do something, but to do it automatically without the need for a human to actually be there to provide governance and oversight. Characteristics, right? So here's where we kind of get into cybersecurity type thinking and elements here. We have delegated. So think of delegated. We're all familiar with the term bring your own device, BYOD. This is almost like bring your own AI. These could be agents, applications that humans are actually onboarding into environments to help them do things more efficiently and effectively. So we think about like collaboration platforms and other tools that might have AI built in. They might have the built with AI stamp or something, but it likely could have an agent on the back end that's there doing something, right? So these are going to inherit and follow the permissions of the user that brings them into the environment. For a single user, this could mean, okay, it can access a single user's data. For a privileged user or for an application, right, it could have actually access to a very large, expansive set of data that agent can now have the ability to, it's been delegated permissions for. We have ephemeral agents. So these are kind of created on demand for a specific task. Think about traceability. Think about the ability to audit, like when something is spun up and then it goes away, right? So that's very, very important and an element that we want to consider. We have fully autonomous agents that are there. Think of that task-based or the custom agent that's doing things without direct supervision. And then we have distributed. So this is like the amplification of a lot of agents that are interfacing with each other, that are communicating, and that are working towards accomplishing a common goal. These could be interfacing with external agents that the organization has built and trusts. Could be external factors. So think about traffic management systems and smart grids, taking data from a lot of different sources to make these automated decisions in real time. This is very important. Emilio is going to dive into what you see there in the red, in the shade of red, in just a few minutes. But when we think about modern identity and access management, we can't discredit the need to actually provide that same level of coverage for agentic AI. So, today we have to worry about how do we provision accounts? What is the life cycle? How do we authenticate? How do we provide authorization? How do we audit, right? We just can't ignore that when we're thinking about agentic AI, right? So very, very important when you actually look and compare what we're used to, what's part of our current programs today, and where we need to go, and where we need to think about how do we actually start to kind of rein this in under the identity and access management governance and processes and technical controls for our agents. So this is the evolution, right? We're living through this, whether we realize it or not, right? We started off with basic AI agents that are just there based upon a very trained data set that the LLM is there sitting on top of. We now have the ability to do retrieval with, when you see the term RAG, that's retrieval augmented generation. So that allows the model to actually pull in data from external sources to help ensure that everything is updated. It's not providing stale data. It can also help preventing its hallucinations and other factors, right? And now we have, if you think about it, we have the retrieval and we have the actions. That's our task-based agents that we had in the previous slide. That's the doing, right? It's not just spitting the data back out, but it's actually going to take that data, break it down into a series of goals and do something with it. And now we're moving into the multi-agent systems, that distributed type architecture. A lot of things happening very, very fast. So what are the challenges, right? As you can imagine, think about just the attack surface, right? We now have a new type of identity that we might not have governance around. We might not fully understand what are we using this for? What should it be accessing? We don't have governance, right? So now we've expanded the attack surface. Think about the scope of data that a lot of applications where AI agents are part of the integration. The agents can touch a lot of very sensitive data, has access to a lot within the organization. From the old days, we would equate that to like a privileged identity or privileged service account or service principal or something like that. And we've built controls around privileged identities, or I hope we have. But oftentimes with AI agents, we don't think about those in terms of just the power that they have. And then just the entire life cycle, right? Centralized models are starting to come together, and we'll talk about, and Emilio will talk about Google Agent Space, how that's used today. Microsoft has Microsoft Intra Agent ID that I think they just announced a few months ago. So think of like Active Directory and Intra ID and things like that for the identities that we are used to. It's coming, but we can think about it from the centralized perspective or the decentralized model, which most agents today are kind of under that decentralized model. So we need some sort of cryptographic verifiable identity. We need attributes so we can actually validate and authenticate based upon the distributed nature of agents. This is all part of our life cycle, right? That we need to figure out how do we tackle this. Just the size and scale, right? This is orchestration, right? This is having the right policies, procedures in place so when agents are being spun up, they're being spun down. We have the orchestration, we have the predictability from our cybersecurity governance perspective around this. If you don't do this, I mean, you can just imagine the nightmare that this has when you have all these agents all over the place that are just multiplying. It can make just detecting, creating that non-repudiation very, very difficult. And then we just have the scale of it all, right? And then we have, I don't know if IAM solves the challenge that we have here, but it's still important, right? There are security controls that can help with this, but this is really abuse, right? So it's an adversary trying to do prompt injection to think about like SQL injection or other things to abuse the agent to get an unintended action out of it. We have the privilege escalation, think about cascading chains agents. Yes, maybe the front-end application can only talk to this one agent who doesn't have access to the crown jewel data, but it has a trust relationship with another agent, or it has the ability, there's some integration. So then, attacker might be able to chain and trick the AI into pulling back the data that might be like 3 layers down from the sequence. Then we just have abuse, right? This is adversaries abusing agents to do bad things, deploying ransomware, I think you heard in the talks this morning, they were alluding to this. Not a lot we can maybe do from, I think maybe there's some things we can do from the IAM perspective, but this is also just cybersecurity hygiene and controls, and Emilio will talk about some examples how we do this in Google Cloud today. So before I turn it over to Emilio here, we think about like these 6 concepts, right? We do this hopefully today in our IAM security programs. These aren't new terms by any means, but what I want everyone to now start thinking about is, okay, well, what does this look like? How do we actually pull this off? So with that, I'm going to kick it over to Emilio, who's going to deep dive.
Perfect. Thanks so much, Matthew. Okay, so first we need to understand how is the traditional identity and access management. And it's one of the main issues in the cloud to have this governance, and it's one of the main problems that we have. So a lot of attackers try to access to our cloud. In this case, for example, in GCP or also in Azure, you have a traditional AAM where you delegate some roles or permissions to users to service accounts. So this is inadequate for multi-agents. We have different issues like limited context awareness, credential proliferation, scalability issues, long-lived credentials. So before to start to architect this new kind of identity part for multi-agents, we need to understand how is the multi-agentic layered architecture. So in this case, we have different key components. In these key components, we have our input layer, output layer, but the main way to manage your agents is with the agent coordinator. That is our orchestration layer. In this case, we will maintain the memory and state and different kind of tools that will provide a connection with data. We can deploy different AA agents that we will define different tasks, different retrieval of information, and we can generate different response. The next layer is data, where we are going to process and maintain the long life information. Very important with the part of agents or RAG, for example, is that we need this integration of LLMs with our industry data, so we can respond with our information. So that is very important. We have this data storage layer and the integration with tools. How many of you haven't ever listened to the part of MCP, A2 agent, epicals? So in this case, you can integrate with MCP and secure ways different integration of tools to do different tasks. Finally, we have an horizontal layer that is a part of governance and guardrails. In this case, we are going to implement the controls that can focus to reduce the risks that an adversary can try to do malicious things. So, taking in consideration the proposal from that Matthew mentioned is, okay, we need to move to a next schema where you need to define a tech stack so you can provision the respective components to create your agents. Next, we need to define a timeline of the agents. It's too common that different kind of applications want to use the same agent, but that agent can have access to information that maybe some users should not to have that information. The part of authentication, that is to provide the communication with different kind of tools, and also the authorization. In this case, it's very common, for example, in a cloud architecture, to implement the part of role-based access controls. However, with the part of agents, we are moving not also to role-based access, also to attributes-based access control to have a fine-grained authorization. And the next one is the part of auditing. We need to constantly monitor the logs. A lot of orchestrators, like for example, Smith, can give different logs. So we are going to talk a little bit more about that and the privilege that you need to implement. Sorry. So what happened with the part of authentication? For example, in GCP, you can use Workforce Identity Federation. In this case, it's a solution that can help us to not use long-life credentials. In this case, if you have an identity provider, you can do this integration with Workforce Identity Federation, and this is a secure way to provide access to different users that want to use our applications that have this integration with the agents. So GCP STS will carry this information from the original token to form attributes that can we use in GCP. So this is the flow. First, you need to do this integration with your IDP. Could be Entra ID, could be Okta. So the user will interact with your application. Your application will send the request token to our security token service. The security token service will evaluate based on a workflow that you need to modify, and with the respective response, they will give access to our application. So the next part or the next level is, okay, the user have access, but to what information from the company they have access? And this is the part where we are going to implement ACLs, control lists. In this case, for example, in agent space, you have different connectors. You can connect, for example, SharePoint to your agent space. Once you connect this SharePoint to agent space, you will retrieve the sites, the data, and that information will have ACLs. So the next part in GCP is that the Google Cloud will do this ACL mapping. So we are going to index this information in agent space with the ACLs and the data. So for example, if a user A have access to site B and site C, but user B doesn't have access to that site, with the ACL that we're indexing with the documents, the user B will not have this access. We're limiting this with Workforce Identity Federation and with the ACLs. So we need to combine or mix these three solutions. The part of Cloud AIM to reduce the resources that you are going to use in GCP, Workforce Identity Federation, and the imported ACLs. In a high-level architecture about agents, in this case, it's very important to note that you have different kind of orchestrators. Agent space is an enterprise orchestrator, but for example, LangChain is a more common user orchestrator. So you need to understand what is the responsibilities that you have to implement in the respective cloud. In this case, for agent space, for example, we create a tenant for you, so you can only decide what applications do you want to integrate with different connectors. You need to provide a project where you are going to configure Workforce Identity Federation, monitoring, audit logging, and you can implement different kind of controls. So we are going to explain a little bit more about this part. The first thing, thinking in a layered architecture and also in a less privilege, is to implement Resource Manager and Cloud AIM. With this, you are going to limit to what resources the user can have access, or the agent space in this case. Something important about agent space is that you have data stores that you can use in only one project bound. So in this case, you can't share these kind of data sources between different projects. The AIM is applied to the project, and the user will have access to all agent space apps in a project. So it's very important that here we see that you need to implement agent space only in one project, and all the data sources should be in only one project, but also you need to limit the resources that the agent will be used. To implement the second part of less privilege, we have the part of authentication and authorization. Thinking in agent space is like, okay, we have a connector. This connector will integrate with SharePoint. But if we think something more agnostic, it's like, okay, we're integrating our agents with MCP to another tools to retrieve some data. Taking this in consideration, we need to ask, okay, does the connector or does this integration have the right credentials to access to the instance, to our agents in this part of authentication for the integration with data? And for a user perspective is, okay, how you are giving the access to agent space, how you are giving the access to the agents. Maybe you are using a third-party application like Okta or 1P, that could be Cloud Identity. And authorization. With the part of authorization, what permissions do the connector have? Or finally, the user, what documents can the user access? So like I mentioned previously, with ACLs, you can implement this part of authorization for agent space users. Another point, the part of segmentation. Thinking like a zero trust model, we need to segment the communication between our applications and our services. VPC service control is a very particular solution for GCP. Not all the clouds have this kind of solution. However, the mindset that you need to implement is, okay, how they are communication, how is the communication between our app users to our services, to our agents that we are building. Also, you can mix with a part of IAM ingress rules. This is important because the next level about agents is not only to have all in the cloud, will be an hybrid architecture. So taking this in consideration, how you are going to have this division and segmentation, so you can improve your security posture. Another good point is the part of data. Like Matthew mentioned, we need to understand what data is used by the agents, how we are managing our data. So for example, in this case, you have DLP in GCP, and also you can use Security Command Center to use the part of auto-tagging. Sorry. You can also implement the DLP to discover, to classify, and to protect the information that we are using with our agents. Tokenization of personal identification information, that is very important. And finally, mask unstructured data. This is important because when you are trying to, for example, create, in this case, grab agents with Neo4j, that is very common, you have different kind of databases that you need to mask. You don't understand all the things that you have. So it's a good way to implement a control for the part of data. Logging and monitoring. So it's important to have the visibility. Like Matthew mentioned, somebody can try to use a chain attack where an agent can attack, or how can I say, spam another agent to do different kind of things. So taking this, in GCP you have three kind of logs: agent space activity logs, access transparency, and access approvals. However, if you are using another kind of orchestrators, it's important to forward that kind of logs to a centralized part, like a data lake, like an S3 bucket. And finally, prevent to who have access to that data. For example, if somebody of your developers have access to Langsmith, that is a common way to check the logs of your agents, you can have a personal identity identification information. So it's very important to implement the role-based access to the users that need to access to Langsmith of this kind of information. Okay. Finally, the part of guardrails. In this case, GCP have a model armor. Model armor, you can consider this like a LLM firewall, but the main focus is to protect your model from prompt injections for different kind of attacks. In this case, for example, you can see the user interacting with the model. We pass all the input and output through this element. So if we detect that maybe the LLM is giving a response with possible data exfiltration, model armor will stop that. So it's a good solution that you can implement to your LLMs or agents architecture. So the implementation. A good way to see this is, okay, you have different layers, like we mentioned previously. So you can focus in the high level, like a content policies, harm and risk analysis. What could be the purpose of the attacker want to use our agents to provoke maybe the creation of a ransomware code, could be, no? So we need to implement this kind of content policies. We need to implement a harm prevention. We don't want that maybe the agent could respond with a bias, for example. And finally, the responsible generation. So with this, you need to focus your safeguards in the part of input, output, and also you need to do a fine-tuning model so the LLM and the agent can respond with the things that you need. It's very common that you need to implement, obviously in this cycle, the part of evaluation and adversarial testing. So with these safeguards, the proposal is to have a centralized approach. In this centralized approach, we have a hub project, agent hub project, where you will have different orchestrators per how you are using your agent. So for example, if you have a human resources app and you have different kind of agents, you will have an orchestrator for that kind of vertical agents. Also for finance, CRM, whatever. You will have a common layer for policy, security, rules that you can implement, audit, logs, secret management, and finally, you have this identity and access management in only one place. This is for a single audit point that can enable a better governance and also better security guardrails, policy enforcement, data lineage, new application onboarding that is very important. You will see this, but some companies is, okay, I need this agent in less than 1 week. Okay, so with this kind of approach is a good way to improve not also the security, also the operations. Agent templates, that is very important. Talking with a friend is, okay, we need these agent templates because sometimes the company doesn't know what they need. So with agent templates, you can also implement security, and finally, resource optimization. So this is a proposal, and also you can see another column that is a part of tool management. So you will have visibility of your agents, visibility of the tools that you are using to retrieve information or do different kind of tasks. It's a good way that you can implement or try to force your new agentic architecture.
Everyone got all that, right? All right, awesome. So, a roadmap, just like anything, we have to create milestones, right? We have to make this practical. We have to make it achievable. You're not going to do all this at once. This is a lot, right? I mean, this is just like examples that Emilio shared is obviously very heavily focused on how we do it at Google Cloud. But, there's just a lot of different ways. So I think I'm not going to read off everything here, but I think it kind of equates to like 3 different phases, if you will. So wave 1 is the planning. It's understanding why do we need the agents? What are they going to be doing? And start to create that the mapping of the governance, but also based upon the use case or the business need of the agents. What are the guardrails? What are the boundaries that we need to create? I mean, some organizations, we've actually kind of whiteboarded this, draw it out, and it starts to make a little more sense, right? So just like a human identity, right? When you know what he or she would need access to, right, you're going to start kind of building the guardrails for authentication and authorization and session, duration and all that. You can still do all that with agents, but you really need to plan it out. Where organizations, kind of go into the deep end too fast is they don't even do this planning. They just onboard things, and then, it's kind of the Wild West. So really wave 1 is all about planning, understanding. It's also hopefully the business is coming to the security team and the IT teams to let them know that, here's the business need. I realize in reality that doesn't always happen. But, an effective program, right, it has the planning. Wave 2 is the building, right? It's not just deploying, from the initial design, but it's building, it's testing, it's the validation. It's the validation not only from like the adversarial perspective of red teaming and all of that, but it's also, do we have the right visibility? Do we have the right playbooks in place? If we detect an incident or we detect, some suspicious behavior, how do we actually go and then pull back the access from agents? Think about it from the human side. Like we have playbooks where we can reset passwords, we can disable accounts, right? We can do things to reclaim positive identity back for our human and even our devices. We have to have the same plan in place for our agents, right? So that's kind of wave 2 is the planning. Wave 3 is the actual deployment, hopefully in like a staged approach. And this is a very, it's a very repeatable process, right? So just because you go from the plan, build, deploy, you don't stop, right? You will be continually testing, validating, and you're probably going to have a new set of requirements that you have to go back and address. So this is the approach where you kind of break it down into these waves, if you will, and really time, right? Time is the factor here. Understand some organizations have to move super fast with this, but it really is important to try to kind of align like this strategy. And then it's manageable, it's measurable, and it's also something, that organizations, this is how you build your governance around agentic AI through this approach. So I think that's all that we have. I know that we wrapped up a little early, but if anyone has any questions, we're happy to answer them.